Okay, so in today's lesson we're going to carry on with probability. What we're going to look at specifically here is how to draw a sample space diagram. And a sample space diagram is helpful if we are looking at probability questions where we're doing two things at once and trying to work out all the different probabilities that could happen. So in the first question, what we're going to look at is, say, if we were to toss two coins. If we were to flip two coins, we've been asked here how many possible outcomes are there. So if you imagine that flipping two coins and the way they land and recording the outcomes. So flipping two coins, they could both land, for example, heads and heads. Okay, they could both land with two tails, or they could both land with a head and a tail. And you'd be forgiven for thinking then on the basis of doing that there's only three outcomes. However, what people quite often forget, if you were just to simply lay your outcomes out in that fashion, is that you're forgetting one of them, and it's a very easy thing to do, because what you're doing is you're thinking that a single head and a single tail is one outcome in itself. What we do is we draw ourselves a sample space diagram, and I'm going to do it in the format of a table here for this question. Okay, so how we do that is we set it out in rows and columns with the outcomes for each coin individually written. So across the top for coin 1, and it's two outcomes. Along the top of the table it's going to be heads and tails. I'm just writing H and T for short. Okay, and you'll of course be able to use a ruler for this and do it much neater than I am. Down the side I'm going to have coin 2 and its two outcomes, which of course are also heads and tails. Okay, so what we do is we match the row with the column, and in here we should have 1, 2, 3, 4. You can also add, again with a ruler, extra lines in to realize that there's actually going to be 4 outcomes, and this will allow us to see specifically what they are. So in here this will match coin 1 with coin 2, a head and a head, so H and H. So that is if we were to get this outcome, is if we were to get two heads. This outcome here is heads and tails, a head and a tail. And this is the one people will normally forget about. This is a tail and a head. And the reason you might forget about that is because you might think these are the same outcome. They're of course not. One's a head and tail, and the other is if the other coin was the land tail and the other coin from that was the land head. And then in this last box here, it'll be a tail and a tail, again matching the row with the column. So if we were to flip two coins, there are 4 possible outcomes: a head and a head, a head and a tail and a head, and a tail and a tail. And they are all equally likely. So any one of those you have a 1 in 4 chance of getting if you're to flip two unbiased coins. So if I was to be asked a follow-up question on that, so what is the likelihood of getting two heads? Well, it would be 1 out of 4. And again, that's that idea of getting, so the probability of getting two heads is simply 1 out of 4, and that's that idea of very easily writing it as a fraction. Okay, if I was asked the probability of getting two tails, well, it would also be 1 out of 4, because there's only one outcome with two tails. Now, if I was asked what is the probability of getting a single head and a single tail, not really specific in terms of what coin is the head and what coin is the tail, well, then that is 2 out of 4, because there are two outcomes where we get a single head and a single tail. Also here, a single head and a single tail. And of course, as I pointed out last week when we looked at probability, 2 out of 4, you could simplify that to a half. Again, it's always good practice with fraction questions to simplify your answer, though with probability you're not asked usually to do that, so either answer will be acceptable in that case. Okay, now we're going to move on to a slightly more difficult question and commonly asked question, is where two dice are thrown. So these questions are asked quite commonly. It's something that you do. You play games like Snakes and Ladders and Monopoly, where you would throw two dice, and you're asked what is the probability in these types of GCSE questions of getting certain outcomes. And there's two different ways we can set out the sample space diagram for these if we're doing it in a table format. Okay, so they also might, depending on the GCSE question, asks you to do different things, such as maybe multiply the outcomes of each individual dice, but we can cross that bridge when we're doing some of the past paper and practice questions. So 2 dice are thrown. What's the probability of getting a total of 12? Okay, so if we think of the outcomes alone, if we were to roll 2 dice, okay, so the smallest outcome is if you were to get 2 1s, and 2 1s added together gives us 2. So the smallest outcome is a 2. The largest outcome is if we were to get 2 6s, which would be 12. Quite commonly in games as well. If you get a 12, you get another roll. Okay, so we can get anything from between 2 and 12. So between 2 and 12, you can get 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that is 11 outcomes. So again, you will be forgiven for thinking that the probability of, say, getting a 12 is 1 out of 11. However, if I was to then put it to you, how many different ways can you get a 12 when you roll 2 dice? Well, there's only one way that you can get a 12, and that's if you were to land 2 6s. However, if we look at part B, getting a total of 7, there are a number of different ways that we can get a 7 when we roll 2 dice. So you can get a 1 and a 6, a 2 and a 5, a 3 and a 4, and you can also think of the flip of that if the other dice would say to be 4 and 3. Alright, so a sample space diagram is an ideal way to set all the possible outcomes out. So how we do that? Again, dice 1 and its outcomes along the top. 1, 2, 3, 4, 5, 6. That's all the different outcomes on this dice. Dice 2 down the side. It wouldn't matter if you did dice 1, dice 2, by the way. You'll still end up with the same number of outcomes. 1, 2, 3, 4, 5, 6 down the side for dice 2. And because we're adding to get our totals, when we roll the 2 dice, again, we're just matching up with the row and the column. So this is if we were to get a 1 and a 1, which is a total of 2. So the smallest outcome you can get when you roll 2 dice. 1 and a 2 is a 3, a 1 and a 3, which is a 4, a 1 and a 4, which is a 5, and you see the pattern. So 2, 3, 4, 5, 6, and 7. Sometimes in the GCSE questions, they will start the table off for you, and you just fill in the rest, and it's quite easy to spot the pattern. 2 and a 4, 6, 7, 8, 3 and a 1, 4, 5, 6, 7, 8, 9, 4 and a 1, 5, 6, 7, 8, 9, 10, 5 and a 1, 6, 7, 8, 9, 10, 11, 6 and a 1, 7, 8, 9, 10, 11, and 12. 12 being the highest possible outcome we can get when we roll 2 dice. Okay, so on the back of this, these are all our different outcomes. Now, you've 1, 2, 3, 4, 5, 6 different ways of getting a 7, for example. You've one way of getting a 2, 2 ways of getting a 3. In total, there's 1, 2, 3, 4, 5, 6, 7, 8. I could count those, or I could just realise 6 times 6 is 36. There are 36 different numbers within this table, so there are 36 different outcomes. So in terms of probability, each one of these, so I'm just as likely to get this 2 as I am to get this 5. However, getting a 5 overall, there's 4 different ways of getting a 5, where there's only one way of getting a 2. So any probability I'm asked regarding rolling 2 dice is going to be out of 36, and we can again write that as fractional. So the probability of getting a 12, again part A of this question, there's only one way to get a 12, which makes sense, is if I was to get a 6 and a 6, is 1 out of 36. Okay? However, part B, I'm asked what is the probability of getting a 7? Well, there are 1, 2, 3, 4, 5, 6 ways of getting a 7, so there's a total of 6 out of 36. So it's just something that, again, to actually keep in mind if you're playing any games that involve rolling 2 dice. The most likely outcome is actually getting a 7, hence the expression lucky number 7. 7, there are more possible ways of getting it than any other number when we roll 2 dice. Not that I'm encouraging anyone in any way, shape or form to gamble, but it's just something to keep in mind. So 6 out of 36, which is simplifies to 1 over 6, again if we're thinking of simplifying fractions. Okay, so probability of getting a 7, 1 in 6 chance, whereas the probability of getting a 12 is a 1 in 36 chance. Okay, And again, if I was to ask, if I was to get asked what's the probability of getting a 3, for example, well, 2 out of 36, probability of getting a 4, 3 out of 36, okay? And you see how that works. Now the other way of doing this table, and again, you will usually be advised within the question what way to set it out, is if we were to label it this way, kind of like the way we did the sample space diagram for the coins, where we're putting each with their individual outcomes. So it'll also match up with this other format of the table. So this outcome was a 2, which is a 1 and a 1 if we're adding the two numbers together. Okay, this outcome was a 3, which is given to us by a 1 and a 2. And these tables, sometimes you can actually be asked to use them in conjunction with each other. But anyway, the third part of this question is asking us, what is the probability of getting 2 even numbers on each dice? So that's if when we roll them, say they land just like this, where we have a 2 and a 2. So we're going to have to go through this entire list and look at where we get 2 even numbers. So for example, we have a 2 here, but the other dice landed on a 1, so that doesn't work. Here we have a 4, however the other dice on this occasion landed on a 1, so that doesn't work. So 2 and a 2, 2 and a 4, a 2 and a 6, so there's 3 of our possible outcomes. 4 and a 2, 4 and a 4, 4 and a 6. None of these will work because they all have 5s. 6 and a 2, 6 and a 4, and a 6 and a 6. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So the probability of even number in each dice, okay, even number on each dice is equal to 9 out of 36, which again, if we were to simplify that as a fraction, is simply 1 over 4. Okay, so one of the key things with these probability types of questions is always to read it carefully. Okay, sample space diagrams can be done for loads of other different type of examples. So say for example, if I was to, I'll just do another quick one here. If I was asked to flip a coin, okay, and roll a dice, and again, if you imagine flipping a coin, you have 2 outcomes, you have heads or tails. On a dice you have 1, 2, 3, 4, 5, 6. So if I wanted to work out all the outcomes, so like a head and a 1, a head and a 2, that's an outcome, for example. I can do a sample space diagram. So let's say, it doesn't matter what you put along the top, say it was the dice. So the dice has outcomes of 1, 2, 3, 4, 5, 6. Then the coin down the side has outcomes of either heads or tails. And we just match the row with the column. So this is if we got a head and a 1, a head and a 2, a head and a 3, a head and a 4, a head and a 5, and a head and a 6. Tail and a 1, a tail and a 2, a tail and a 3, a tail and a 4, a tail and a 5, a tail and a 6. So 12 different outcomes. Say I was asked was the probability of a tail and an even number as well. None of these all apply because they're all heads. So a tail and an even number, 1, 2, 3, 3 out of 12, 1 in 4 chance of that happening if we were to simplify. Okay, so it's all about practice when it comes to probability, reading the question carefully as well. Again, I'll give you some questions and work to practice here, and if there's any issues at all, always just feel free to ask.